We call this the slope-intercept form because we have the slope and the y-intercept. The y-intercept is where the line cuts through the line graph at the y-axis. So we're gonna first talk about slope. Slope is denoted as the formula is the change in the y values over the change in the x values. At the same time, I guess I could talk about how you could get in with this, with the other formula, which is the point slope form. If you multiply both sides by x minus x1, you do get m times x minus x1 equals y minus y1. And if you bring the y constants to the other side, so you have y minus y1 equals m times x minus x1, and we have a clever name for this. We call it point slope form. Yeah. So basically, if we're giving any 2 points, we could just use we could find the slope first, and then we could use one of the points to plug it into the formula. So for example, let's see. So -6, 8 and 4, -10. To find the slope, we just first we'll label. So that's of course x1, y1, and x2, y2. Plug it into the formula. We have m equals the difference in the y value, so that's -10 minus 8, all divided by the x value, so 4 minus -6. We can simplify this a bit. -10 minus 8, that's -18, over 4 minus the -6, that's the same as 4 plus 6, which is 10. We can simplify this if we wanted to, because we could divide the numerator and the denominator by 2. If we do that, the final answer is negative, with out front, -9/5. That's the slope. Let's just record that, -9/5. We could try another one. What if we were given the slope -1/4? I hate a fraction. 3 and 4, -1/6. Well, first we'll need to find the slope again. So that's the difference in the y values. So -1/6 minus 3. So slope is -1/6 minus 3, all divided by the difference in the x values. So 4 minus -1/4. So if we wanted to simplify this, first we need a common denominator. 3 is actually 3 over 1. So if we multiply the top and bottom by 6, we get -18/6. We get 18/6. And then subtracting that with -1/6, we get -19/6. All divided by, again, this is 4 plus 1/4. So 4 is actually 4 over 1. So 16/4 plus 1/4, that's actually 17 over 4. There's a few ways of doing this problem. This is called a complex fraction. it is called a complex fraction because there's both a fraction on the numerator and the denominator. One way to get rid of fractions on the bottom is to multiply by the least common denominator, the LCD. Once you do that, you could make it simpler. Or the other way is to take the bottom fraction and invert and multiply. So in other words, take the reciprocal, which is 4/17. Let me show you that way. So first I'll treat this as a regular division problem. And next I'll do what I just advertised. I'll invert and multiply. For me, one of the easiest things, if you like, is you could simplify the fractions first. Or you could just multiply straight across. I like to simplify a bit. So 6 goes into 4 twice. So 3, 2. So now I could simplify this. That equals... Okay. Negative 19 times 2. That's... So negative 38 over 3 times 17. That's 51. That's your final answer. So let me recap what I did, and then we'll end the video on a high note. So then I could talk about the other methods. So your slope, let me just write it, is negative 38 over 1. Just in case, if you wanted to know the other method, I'll show you the other method. So if you had a fraction, negative 19 over 6, this is not relating to this because this is the other thing, over 17/4, you could do what I advertised. Basically, if you get a common denominator, which is 12, so multiply the top by 12 and the bottom by 12. So once you do that, 6 goes into 12. 6 goes into 6 once, and that's twice. So you get the same answer, negative 38 over, and then 4 goes into 4 once, and that's 3, and 3 times 17, basically that's 51. So you get the same answer. You see how like it doesn't matter how you solve it. Now, if we're adding fractions or subtracting fractions, it'd be different. But I'll talk about that on another lecture. Not right now. Yeah, you get the video. Boom, we're done for right now.